Hi there, Michael. Hello, Michael. Hello, Michael. Hi there. Hi. Can you hear me? I can't hear you. I can't hear you. But can you hear me? Can you hear me? So, okay.
Oh, no.
Yeah. Hi there. I can hear you now.
Okay, good. For some reason, the microphone was turned off automatically. I don't know why. That was my hardware. How are you?
Yeah, I'm doing okay. Didn't get a lot done this week, but I've got a few ideas about where it's going as regards the SQK Model G stuff we're doing.
Well, you've been getting a lot done.
Well, I can. Let's have a look here. This chat. Close chat. Okay, open chat. Probably best to open it. Okay, well, I can show you. Let's just share the screen.
Okay.
Can you see that?
It's coming up. Yeah.
Okay. Well, what I found out was that we need to produce. I produced something like that. Whoopsie. I produced. Can you see this bit here? It's split up into this one and this one. If you can see that. So I was trying to produce something like this. Can you see here this first one here, where my mouse is scrolling over?
There's like 1, 2, 3, 4, 5 terms.
Yeah. The one. This one here. Can you see? I'm trying to get the mouse to thingy-majig and it won't do it.
Where's
where my mouse is? Can you see where my mouse is pointing?
Yeah.
Yeah, that one there. Okay, it's been broken up into this one and this one, and I started to try and do something like this in regards to Model G, the first gravity term, which is let's have a look here. So if I go to it looks like it might be a little bit complicated when we get to two dimensions. Can you see this is not my... I was having a little bit of problem. I was going to write an email about my laptop because here it's working now. Okay, let's just... okay. So we go down to 13. So this one here, can you see that?
Yeah.
Yeah.
The
so
G gradient.
So I was trying to convert that into the Crank-Nicholson method. I splitting it up into it's like this one here is split up into these components.
All right.
Right. And actually, I've got something. No, it's let me see if I can just give myself and send myself an email, because on my other computer I started a bit of note writing on it. Let's have a look.
Okay.
I'll just send myself an email. Hold on a minute.
Has anyone else said they were going to join the meeting today, or will it just be you and me?
I don't know yet. I hopefully that whenever looking from the past, it looks like people were joining, sometimes a bit late.
Okay. Yeah. Sometimes even an hour late. That was me.
All right.
Right?
Let me just see if I can get this thing.
How's the weather over there in England right now?
Yeah, it's quite nice. It's sunny weather.
Is
Sometimes
it?
a bit cooler, but it's mainly sunny at the moment.
It had been sunny here, but then we've got a little bit of some cool, rainy weather right now.
Mm-hmm.
I never been to Ireland, but I kind of just imagine that that's kind of what it's like there.
Mm-hmm.
One day I'll visit.
Yeah, you can see. I don't know if you can see the back of my. Can you see the light out there?
In the window, yeah.
Yeah, that's. But it's kind of like it's evening time, 8 o'clock. You know, so it's fairly good sunny weather.
Mm-hmm. Oh, that's awesome.
Anyway, it looks like this one here. Can you see? This is the matrix form. They've showed this partial differential equation here, and it's just a equation. If it's 2D, that would include x and y, but it's 1D. They split it up into these components, and then these are constants here. And then they've written it. So the j plus 1 is time, and the I is displacement. I minus 1, I plus 1, all this kind of thing. Then they've done a boundary condition, which I don't quite understand very well. But and then they've drawn this they have this matrix here. Can you see this matrix?
You're all right.
Yeah, and then they've taken that matrix. So they've got AA here, BB here. J plus 1 is the next time component, and J is the previous time component, and D is a boundary condition. And then they've gone down here and they've got this here. So they split. They've taken this one, this one here, and they put it in matrix form. Matrix forms AA1, AA2, AA3, like that. So that one, this one here, and this one here, they're 12 times 12 matrix, just made to look smaller.
Okay, right.
Then it comes down here, and then they rearrange this matrix equation so that this becomes an inverse, and they get out the time, the next time component. So you can get out. So C is what they're looking for to solve the different partial differential equation, and they rearrange that previous matrix equation to get this one. So that gets the time components out.
Yeah, that's a big part of most numerical analysis is converting everything into matrices.
And can you see this 2D diffusion? So they're giving the example of a 2D version. So you've got X and Y here. Look, it produces something quite bigger here, but they're saying down here that this can't be, this has to be solved. Solving such a linear system is not practical due to the extremely high complexity of solving a linear system by means of Gaussian elimination or even Straussian algorithm. Hence, the alternating direct implicit method can be implemented. So I went to this one here. And it looks, so we're getting ourselves into sort of reasonably deep water with the maths, alternating direct implicit method.
Well, that's one thing Matt was particularly good at is he majored in mathematics.
He mathematics or physics? He did
both, but I believe I'm not sure. Maybe the one was a minor, or he might have double majored.
He was stronger on the maths, was he?
I would say at least as strong. Yeah.
And he was.
Yeah.
Paul Laviolette was saying he was top of his class in MIT, which sounded pretty
good. I thought he went to UCLA.
Oh, right.
But,
okay.
Yeah.
The benefit of the strategy is that the implicit solver only requires. So anyway, it goes to this alternating direction, and it looks pretty hairy. So it doesn't look like it's that simple to solve, say this one here, this kind of to solve that in matrix form may be sort of reasonably difficult. Anyway, what I'll show you is I've just downloaded this. I'll download this. I suppose we can plug on and try and the other option is going with the ETD stepper, and basically because he's done that in 2 dimensions, but it requires a fair bit of research.
So what you're working on right now is how to extend the Crank-Nicholson to 2D.
Yeah. So it can be extended to 2D, but it requires a certain amount of. So what I've done, I'll show you here. What I've done. Let's just. So what I'm trying to do at the moment is go through this one here, try and understand how this works.
Mm-hmm.
Try and write out what they've done here and see what's going on. See how this matrix works out and if it makes sense to me.
Sure. Now, why would you prefer the Crank-Nicholson method over the ETD stepper?
Well, David Johnson wanted to go over it because the code seemed simpler to him.
Okay. Right.
It seemed more intuitive and more straightforward. He was finding the ETD stepper a bit complicated to follow, I think. Right.
It looks like, if I remember, it was just about one page of code versus multiple pages of code with the ETD stepper.
Download.
Yeah.
And so to downloads. Okay.
And you've already ran the Crank-Nicholson in 1D, right? You plotted those results?
So one method is to use Matt Pulver's Crank-Nicholson method and see how he's done it in the code, and then try and compare that to what's trying to compare it with this method here to understand what he's doing. To understand what he's doing. So let me just get this thing up here. Okay, I'll just put this down. This up. Go to stop share. And then I'll go to share. Can you see that?
Nothing yet.
Can you see that?
Something's coming up now.
Okay.
Yeah.
This was this sort of like academic notes that I was writing. They're not really. It's not a proper paper. It's just notes. And also remember, Paul Laviolette had mentioned the Schrodinger's equation is another one we can try. Trying to adapt Schrodinger's equation to be compatible with SQK.
Which equation was that again?
Schrodinger's equation. So the one that it's kind of like fundamental to quantum mechanics.
Right, the probabilities.
Yes, it's probability. It's a wave equation, which basically explains how a particle and a wave interact. I may be getting this wrong, but it describes the wave function. Got the wave function in it, and it describes the relationship between the wave function and the particle that you're analyzing. So here we go. Crank-Nicholson solver down here. Can you see here? So driving Crank-Nicholson's method in 1D model G. So that's the equation relating to geons, and I've just converted it to make the mathematical symbolism more easy to G. I put the phi G, made it G there. Then the Crank-Nicholson solver, we got that for the double differential equation. Got that term, and then these terms here. And then I was trying to put it together. As you can see, this one hasn't been done properly. This one hasn't been done properly yet. That's the same. I was getting the code off Wikipedia, the things.
Just kind of put that in there as a placeholder for now, right?
Yeah. So that will be, convert that to be something like this. Can you see that? And then notice it's also got exons as well. So it's not just it's not just G we're solving for, also requiring X in there.
Uh-huh.
I'll write a note to the others asking if they're going to join this meeting.
Yeah, it's about 15 after now.
Let me just draw out.
I hope I already wrote my mom for Mother's Day. I don't know, maybe a lot of the team members are spending time with their mothers. I don't know. I'm on the, well, my mom's in Texas, so
Okay.
we're a little bit ways away.
Hi guys.
Yeah.
I have started the meeting with Michael. Is anyone else coming? Coming along. What do you think? Do you think we should wait a little? Do you want to continue going on with the meeting, or do you want to sort of like wait till they come along, wait and see what happens?
We can give it a little bit longer if you like.
Yeah, I've started the meeting with Michael. Is anyone else coming too?
I'll make a little bit more progress on my hardware, but I'm not there yet. I might have another laptop to work with here by next week, but I have to do some more work on it.
What's that in the respect of?
Well, I might be able to dedicate that laptop to some simulations, possibly.
Yeah.
Yeah.
So it looks like this Crank-Nicholson solver is I mean, even the 1D is a bit tricky. It's not, you have, you work out, because what Matt Pulver's done, he's done all this bit here, he's done all of this here, he's put in code form, C++ code form. And then he's done something like this here, I should imagine, to get the values.
Right. Yeah. Well, I remember when speaking with Matt is that he said the Crank-Nicholson ran a lot slower. It was a lot more computationally intensive. So I think he already tried out the 2Ds with it, and that's kind of why he shifted over to the ETD stepper. But if it's not that difficult to try out, I don't see why not.
Well, so he's already tried Crank-Nicholson solver for 2D and it didn't work out.
Well, yeah, that was why he switched.
All right.
Yeah.
Okay.
But I guess it all depends on the parameters of your simulation. If it's simple enough, maybe it's not an issue.
Well, David Johnson said even if it's longer to run, he was maybe thinking it was better because he thought it was more intuitive.
Right, and computing performance has improved since too also. So.
And there's also this one to look at, which is the Crank-Nicholson in 1947, writing out this method here. So it's a reprint from 1947.
That's pretty impressive that he was even thinking about that in 1947.
Yeah.
They didn't have computers that I know of. Maybe some mechanical ones.
I think that Alan Turing had one working by about towards the end of the war, about 1945, 1944 time, I think, around about that time.
Yep.
So
it was just coming out, yeah.
So the idea was there, and they could probably played around with the idea, because I noticed down at the bottom here, he's talking about machine. He's talking about...
so this is groundbreaking.
Machine, can you see that? Machine solution.
Uh-huh. Oh yeah, that
Could be
was
like a Turing machine. That could be like the early computer.
gears and yeah, all that stuff.
So you might be right. It might be better to. It might be better to go back to ETD stepper and try and understand it better.
Well, you're the one working with it the most so far, so that would be your just, you know, your call.
So that
You definitely making a lot of ground, and
because it looks like he's talking down here about solving it in 2D. He's just solving this. I mean, it's a relatively simple 2D, and he's talking at this guy or the person writing it is talking about solving such a linear system is not practical due to extremely high complexity of solving linear system by means of Gaussian elimination. Hence, the alternating direct implicit method can be implemented to solve the numerical partial differential equation, whereby one dimension is traced implicitly and the other explicitly for half of the assigned time step, and vice versa. And that's this.
yeah. Oh, I know with my experience with the ETD stepper, I had no problems running the higher dimensions. It's just my computer was really slow.
Uh-huh.
It still is actually, and I think the biggest challenge there would have been, if I remember correctly, is he didn't actually write the code for outputting the 2Ds and 3Ds. Or maybe it was a 1D and a 2D,
Yeah.
and plotting it graphically with the ETD stepper. But he had everything already written for the 3D, but that was the most numerically intensive also.
I'm just thinking, just made me think about the Mathematica code, the part this one here, because I'm hopefully going to get Mathematica. I tried to buy it offline. A relative of mine lent me some money to buy it. I tried to buy it online, and something went wrong in the payment section. So they weren't accepting my credit card details. So I emailed them, and they said to phone them up and do it over the phone. So this one
yeah.
here, go on.
Well, I mean, I guess another option would be too is I hear MacBooks are pretty nice. If you can get a nice used MacBook, that might be, you know, and then you can get the software from Dr. Violet.
Yeah.
Yeah.
Yeah. Well, I mean, I haven't got a Mac yet, so that
Well, yeah. I don't know how much they go on the on used.
Maybe
nowadays.
the Mac is worth less than the Mathematica.
Maybe.
Second-hand Mac would probably cost you less.
And then you might be able to use it for more things. You know, that's just something that came to my mind. Oh boy, I almost pushed the wrong button and left the meeting there. I was trying to minimize my window. Let's see. But yeah, let's see.
Because he's done this in 2D, 1D, 2D, and 3D, hasn't he? So he's done using a two-dimensional graph. He's expressed the y-axis is just radial, and the x-axis is just radial, and the y-axis is 2D, 2D, or 3D concentration. That's what I think. That's what Justin thought it was as well.
Yeah, I think he was using the Mathematica at first also, but then when he switched over to the ETD stepper, I don't know the reasoning for it right off the top of my head, but I guess it wasn't compatible with Mathematica for some reason. He couldn't, that algorithm, the Runge-Kutta, exponential time differential method.
And look at what he's saying here. C++ code based on modeling the evolution of reaction diffusion systems with multiple reactants in 1, 2, or 3 dimensions.
Oh yeah, you can choose whichever dimensions you want very easily with that code.
Okay, so maybe then we go back to this one then, eventually.
Well, up to you. It's really easy to do on that. There's a text document. That's one component of the program.
That one
yeah,
there.
model-g.text. I think you could just change the dimensions in there by like where it says L.
Yeah.
I think if you just get rid of one of those 50s, it becomes a 2D.
Okay.
And then if you get rid of another one of those 50s, it becomes a 1D.
Yeah. So he could be showing the output as like a 2D surface plot, but it's actually the y-axis is one dimension, 2 dimensional, 3 dimensions.
Yeah.
Because it's difficult to represent it in 3D space because you've got a sphere. It's got like an expanding sphere of waves.
Yeah, well, I think it records all the different dimensions, like but you know, it depends on how you plot it. If you plot it in the XY plane, you know, it's going to look different than if you plot it in the XZ plane. Yeah, but I think all that data is collected in 3 dimensions, though. But for depending on how you set up that text file. Yeah.
Here's the out. I'm just getting the output for the one EGD stepper, so we can look at it. But it looks like this. Can you see this one here?
That looks like that might be in the XY plane.
That's in the XY plane. But is that, can you see, look, he's saying X, Y, Z, T.
It's hard for me to make that out.
So is the color.
X, Y, Z, T.
Can you see X, Y, Z, T on there?
I don't know what he means by that. Maybe, no.
Maybe the Z is the concentration.
I don't know.
Why just placements?
You know, the T makes sense, but I don't know. The Z doesn't seem to be. Yeah. It could be a typo or something like that. Who knows?
And I wondered what I was wondering about this. I wondered, is it showing G, X, and Y ons here, or is it just showing one of them?
That's a good question. I'm not sure. I would presume it's just one.
Yeah.
Yeah. I don't think he really. When he did the XZ in the XZ plane, yeah, he was able to plot the concentration gradients that way, but this way it would just be kind of all overlapping, so it'd be difficult to see.
Yeah. Well,
yeah.
If you're doing a 2D, do you remember the paper?
Yeah. Well, that was 1D, I believe.
He's just used Mathematica.
That was 1D.
Spherically symmetric 3D stationary. So this what I think it is I think the space, he's just showing one dimension of the space. I think on the X, the Y, G, and X, this represents 2 or 3. Here comes Paul. Hello, Paul.
Hi. I'm in Bosnia at a hotel, and they have poor internet service. It goes in and out, so I don't know how long I'll be here.
Where did you say you are, Paul?
I'm in Bosnia, next to the Pyramid of the Sun.
Wow.
Oh.
I'm here.
Is that the really huge pyramid that's underneath soil?
The biggest in the world, yeah.
Yeah.
And we went to the top today and measured with pendulum energy coming from the top. They've also done it with meters. They measured a 28 kilohertz EM radiation coming from the top.
Neat.
I
Did you notice?
explain the whole thing on my website on etheric.com. If you look up Bosnian pyramid, how that works. It's made from quartz. They got quartz in the concrete there. Creates a resonance and produces a CM signal.
Wow.
Sounds very
Did you?
interesting.
I'm here for recuperation after my radiotherapy. So there's reports that it helps raise your immune system to make it able to fight things better. So it's a good time to do it after you do treatment like that. It sort of cleans up whatever's left. You know.
What type of treatment is that, Paul? Is it?
For prostate cancer, it's a targeted therapy where the radioisotope goes right to the cancer patches, and so it's not able. It doesn't affect the other cells as much that way. It uses beta particles. They only have a range of a few millimeters, so it's very targeted. So my radiation's pretty much almost back to normal background now.
Did you ever think of seeing Dolores Cannon's kind of hypnotherapy, where she's cured people of all kinds of physical illnesses like cancer through deep hypnosis? Although she's dead now, quite a few people carry
What's her name?
on practice. Dolores Cannon.
I haven't heard of her.
DOLORUS CANNON. She developed hypnotherapy to go into the synaptinous level of trance, deepest level of trance, and she would often question. She would talk to the people in that very deep level, and when they found out what the problem was, it cured them of either almost any physical illness, cancer,
mind over matter sort of thing.
Yeah, so it was kind of like getting to the heart of the problem. And there's her daughter continues it, and lots of people she taught it in lots of different countries, and they've so you can get it in America quite easily, things like that.
I was, in a way, it was almost like bypassing the mind and getting right to the heart, as you said.
Often she found that, say, for example, a guy was coming to her who was riddled with cancer, and went under deep hypnotherapy. She found out that he couldn't forgive his ex-wife because she said, well, if you don't, because the way his ex-wife treated him, and Dolores Cannon said, well, if you don't forgive her, she will have won, and you'll die of cancer. And so the guy then forgave. He managed to do it in a deep level of trance to forgive her. The cancer left him, and he just things like, it was stories like that, and she said, if we can get them before they go to hospital, it doesn't matter what they've got, whether it's kidney failure, diabetes, whatever, they can get them before they go to the hospital to have.
Well, they say the pyramid energy here and in the tunnels increases the heart energy, the chakra of the heart, so expands the love. Yeah,
that would be a good place to be. One thing I'd recommend, I know lots of people who've cured themselves of cancer, and one good adjunct to maybe you might want to look into is something called Essiac tea. And
I had been taking it for several months.
Had you? Okay.
Yeah, but it's still, it wasn't the silver bullet. I had to really do this treatment because everything else, alternative therapies, didn't work.
What about
cancer is very difficult because it's so encapsulated, and it's difficult for the immune system to get in there.
Did you also try got his name now? Chlorine, miracle mineral solution, chlorine dioxide.
Yeah, I did that, but I didn't do it regularly like other things.
It's difficult to do it. It's a little bit tricky to do it all regularly.
There was
also cannabis oil is supposed to be very
good. Cannabis with high THC content. I was taking that for over a year and a half or something. And that did keep it under control. But then it started to lose its effect, and the PSA started going up. So I caught it in time, I think, and I'll do my next PET scan in a few weeks, and hopefully it will show that everything has been taken care of.
Well, I'll be praying for you.
Yeah, I'll
Oh.
be thinking of you. That's all.
Thank you.
What we were talking about was the fact that we were looking at this. We're just quickly looking at this graph here, and from the Mathematica version. And from what we understand, this x-axis represents the radial distance away from the center.
Right.
These y, g, and exons represent concentrate potentials in three-dimensional stationary particle. So I was looking at the Crank-Nicholson solver, and I was going down here. I was trying to do this kind of method for 1D and find out from first principles, like shown down, which I was writing out here.
Mm-hmm.
It looks like the Crank-Nicholson solver. Michael has said that Matt had problems with it in 2D. That it was much slower, and it looks like that down here for the 2D diffusion. It looks like it requires this. So solving such a linear system is not practical due to extremely high complexity of solving a linear system by means of Gaussian elimination or even the Strassen algorithm.
So, is there a way around that, or do we have to just get a big computer?
It's basically saying they're using this method here, which when I looked at it, looks quite high level mathematics.
Do we need help on this?
Well, Michael was suggesting, why don't we go back to the ETD stepper? Because that's been produced in 3 dimensions. That's been produced in...
We were going to Mathematica, was that?
Yeah, so Mathematica is, where's that?
Has limitations, you're saying, for what we're doing.
Just get it. So that's the Mathematica, which I should be getting. I had a bit of difficulty buying it, but I should be getting it soon. I'm going to phone them up instead of using the internet. And where is that now? Okay, so that's the Mathematica code here.
Well, you need the Mathematica if you're going to be doing the other one?
Well, originally we went to the Crank-Nicholson solver because David Johnson felt it was more intuitive to follow, and he thought, why not do it that way, even if it takes longer to run? Because he thought he was finding the ETD stepper a bit difficult to follow.
Okay, so you're going to stick with Mathematica then?
Well, what I was going to do was, once I get this Mathematica software shortly, I was going to have a look inside here and see if, considering it's been done in, as he says at the top here, it's been done in 1, 2, and 3 dimensions. So I was going to try and investigate that. So it might be, what I'm thinking is the Crank-Nicholson's, or even in 1D, this is all 1D here. It's quite tricky. It's solving these matrix. That's a matrix equation, which is rearranging to be like that to get the solution. And even in 1D, it's pretty tricky. I mean, that code that Matt's done is fairly sophisticated. It's all of, this is just an example of, so what Matt's done is this J1 to this J plus 1, and these distance terms, these are 11, 12, 13, 14. This is distance, and the J is time. So when you've got, say, 100 units of distance, you've got this matrix is like 100 a long matrix, and so is this one. And then this one again is much bigger. It's not, here it says it's 12 times 12 matrix. But here it says 12 times 12. But actually, if you put it into the full program, it's more like 100 times 100.
Wow.
So it's it's doable in 1 dimension. But when you get down to, I didn't fully understand the boundary conditions here. I'd have to investigate that a bit more. This D represents the boundary condition.
Sounds like you'll need more than a laptop to run it, right?
Yeah, and then if you go to 2D, it's talking about that it's fairly sophisticated to. It requires all of this kind of math, which looks pretty hairy maths.
So are there ways of linking laptops together to be able to run in parallel, the whole thing?
Yeah, if David Johnson wants to go down that route and he thinks he can do it, then he was talking about a gaming machine that was like 700 times faster than a desktop.
Uh-huh.
Oh, there was also
$700.
there was also Justin's proposal that we just pay for computing time on Amazon or something like that.
Uh-huh.
Well,
do they have something that's fast enough?
I think it was expandable to whatever your need was. I'm not familiar with the costs.
Maybe would Amazon be willing to give a special price for our work, since we're a nonprofit effort here?
It couldn't hurt to ask. Yeah.
Because Amazon currently, they have a program where people's purchases, part of that can go to any designated charity. And in fact, we do get contributions. Starburst gets contributions from Amazon people who have made Amazon purchase. So it might be worth to ask them that.
Really? So you're on a list of charities for Amazon?
Yeah. So whenever you buy anything, if you designate you want part of it to go to Starburst, then we get a percentage of the purchase.
All right. Well, that's
called Amazon Smile or something like that.
okay. Well, I could probably contact them about that. See what the options are there.
Yeah, they might have also a charity division that wants to help nonprofits, and maybe they might be interested in what we're doing. Since it's stimulation, it's up their alley, you know.
Amazon Smile Charity.
Mm-hmm.
Would that be better than this technique that David was thinking of?
Yeah, I mean, well, I'm just thinking maybe to go back to ETD Stepper and work with Mathematica. For those who've got Mathematica, work with that, and then or then maybe go back to ETD Stepper, because it just requires working through the program we understand it a certain amount anyway. It just requires going through it to understand it more and decide, and then to test this velocity term inclusion. That can probably done more easily in Mathematica.
Would Mathematica though wouldn't be run with Amazon, right?
All right.
It could be.
Not.
You know, it depends on how you set it up.
Would you have you talked to the Mathematica people to see what they might suggest for our problem that we're doing?
Yeah, we could do that. Just talk to Mathematica and ask.
Maybe they have something more advanced that would help, and they might give a special break on it.
Yeah. So speak to Amazon Smile and ask them whether they would take on a Mathematica program.
You could direct them to our Facebook page, I guess, and
yeah,
to see that it's a real thing we're doing, real project.
Mm-hmm.
And mention Starburst Foundation.
Yeah.
Well, I could do that.
Okay.
I could do that. Yeah.
And I think that the inclusion of the velocity term is something that, you know, is something interesting to try, because it could be the right method to start looking at this rotary motion. Paul, you also mentioned that there was something to do with Schrodinger's equation that we could also look at. What did that involve?
Oh yeah, well, subquantum kinetics has an alternative interpretation of de Broglie's wave particle experiment. Instead of having a pilot wave sort of tagging along with the particle, which they represent as a singularity, if you use the particle as a wave soliton, like what we generate. So it has that Compton wavelength embedded in the electric field, and that produces all of the results of the wave particle scattering that de Broglie was talking about.
Yeah.
And the beauty of it is that it's not observer dependent. It's intrinsic to the particle. So it gets rid of all the paradoxes. But the Schrodinger equation is based on de Broglie's view. Schrodinger sort of massaged de Broglie stuff and came up with that version. It produces equivalent results, but you know, it still has those paradoxes.
Have you got a document or like some notes or document that you could send us?
Well, it's a whole section in subquantum kinetics that discusses it. It predicts the orbital levels in the hydrogen atom, and it goes beyond that because it allows an orbit below the ground state to exist.
Yeah.
And that would explain the hydrino stuff of Randall Mills, and explain how he gets his energy. Physicists just deny, you know, because they think it's impossible, so they don't even want to talk about it.
All right, the hydrino. That was the what was that again? The hydrino was a state.
Well,
yeah,
Mills was saying that the electron goes to a lower energy state below the ground state and releases an ultraviolet photon, and that's not able to. Well, the photon, it's a phonon. It's not able to come out as a photon. But if you put the right catalysts that collide with the hydrogen atom, it transfers the energy to the catalyst, and then the catalyst radiates the ultraviolet photon.
Okay, I'll check that out in some quantum kinetics. There was a guy who wanted to come on to this, onto the Facebook page, so I asked him a bit about himself. You see this here? So
if there's a way to do something like Schrodinger did, but with this new model of what's happening, I don't know if it's possible what it would look like. I'm not a mathematician, but, you know.
Okay. Well,
nobody so far has worked on it, but it's something that.
Well, I mean, Schrodinger's equation is supposed to be foundational for quantum mechanics.
Right.
It's supposed to be the key equation.
And it's, you know, we have all the evidence to support our approach being better, but it's a little embarrassing that we don't have something to substitute for Schrodinger equation.
Yeah. So that could be like another project we could look at if we, as another thing to look at when this one is going a bit slower.
Yeah, it's not simulation approached. It's more, you know, mathematical. Somebody knows how to write equations.
Yeah, I believe that's in chapter 4, subsection 9, in your book, right, Paul? Foundation for a New Wave Theory of Matter.
Yeah, right. And you know, to be honest, I don't understand Schrodinger equation enough to understand how he got that. And who knows, maybe something similar to Schrodinger equation and just you interpret the terms differently might work. I don't know.
Yeah.
You need somebody that's really into that stuff. And, you know, probably a mainline physicist, and you just take his nose over if you can get him to look at something new and say, how would you write this? If you knew that there's an alternative way is a better possibility.
Yeah. And Schrodinger's equation is kind of like, let's just have a look at that. I've seen the paper. I've had a look at the paper in the past where he derived it, where his thinking that led up to Schrodinger's equation.
Mm-hmm.
I've seen that. So it's a simple. It's a time. This is time dependent Schrodinger's equation.
Yeah, all these See, I never really got into Hamiltonians and all that stuff.
I mean, Hamiltonian operator, Hamiltonian quantum mechanics. They were making a kind of a special type of algebra for quantum mechanics. And it was like the wave function was, it was like the wave function was kind of abstract. So you got the particle and the wave data out of the wave function. The wave function wasn't physical; it was a completely abstract thing. And they by solving the equation, they got the particle information out of it and the wave information.
Yeah, it was supposed to be virtual in a way, and it's what's called a collapse of the wave function, which would become real at the time of impact or whatever, when the actual interaction occurred.
Yeah.
Yeah. And I think that was disproved too, that there is no such thing as a collapse of the wave function. I think Bohm and BGA did an experiment that disproved the idea of the collapse of the wave function.
Yeah.
I discussed that in the book.
Yeah. So I think that that's something we can do. We can look at the map. When I get the Mathematica program in, I can have a look at that and see how well I can understand it and adjust it to include the velocity term. And you can see here's like 1 dimension, 2 dimension, 3 dimension.
Maybe could you try with just like 5 cells and see if you can get something to rotate? So the computation time isn't too big.
Yeah, I mean, we tried a bit of that with the open foam, didn't we? When we were going to try and set up the open foam and model it in 3 dimensions.
Hmm.
I mean, the main thing, one of the main things is we're sort of, I don't know if we call ourselves amateurs, but we're kind of like some of this kind of project work is like a PhD level. Where you've got your professors and your other supervisors are kind of experts in the field, and they give it and they're guiding you through it. But I mean, my level of physics is the BSc, and MSc I did particle physics, and the BSc level I was the straight physics. But my PhD was in tomography, electromagnetic tomography. But
you know, any physicists or PhD or professors that we could interest in this?
Yeah, that's a good idea. The main thing is when I was talking to the guys, I didn't even mention it to my professor supervisor. I felt that he was far too political but there was another senior scientist who was helping me out on the PhD. I would talk to him sometimes, and I think he was too scared. Sometimes he would admit to me, yes, okay, there's free energy and subquantum kinetics may come about, but he said they have to come about at their right time. So on certain occasions he would deny it and think it was rubbish. On other occasions he would say, yeah, well maybe it's real, he was a bit too scared for his own reputation to start talking.
Right, that's the problem. Yeah,
he did. You know, if I mentioned it to someone else, he said if you tell them I've said it's possible, I'll deny it. That kind of thing. So he's kind of like, and my supervisor, he was very good on his level of what he did as a supervisor. But
like trying to get a Catholic priest to admit that reincarnation is possible.
Yeah. And I think they fear not so much being laughed at, but just by not so much ridiculed, but like other scientists won't take them seriously. But having said that, I think that like Jan Rack is interested, but my impression was that even if the scientists believe it's real, they'll be political about it. They'll deny it. So they might think privately to themselves, yeah, that's possible. But then when it comes to their work, they would like deny it because they politically they think it's suicide or something. I don't know. But
Yeah.
Yeah, it probably is. And
Yeah.
they probably won't have a job very much longer.
Things can change, you know.
Yeah.
But
I've had a pretty negative response myself to the folks that I've shared this type of information with, and propulsion. Some of the leaders in fields of propulsion and just deny it all the way.
Mm.
Yeah. Although but when I did work, that wasn't involved with that. They were there, they were on board with me 100%, so it was a topic. It wasn't,
Mm-hmm.
the personalities or the quality. Right. Yeah.
I mean, even David Bohm was ridiculed, wasn't he, for the quantum potential and the implicate order? He was kind of like, not that I'm not saying that's correct what he said, but he was ridiculed by Oppenheimer. He said, if we can't disprove Bohm, we'll have to ignore him. But
yeah, there seems to be a little bit of that going on. That's for sure. I'm curious, Dr. Violet, were you particular about the SEAC-T that you got? Did you make sure it had 10% sheep sorrel roots in it? Do you remember?
About which one?
The SEAC-T. Do you remember if it specifically had at least 10% sheep sorrel roots in it?
Oh, about the EZAC?
Yeah.
It was the recipe that I was given. I went to a herb store in Glastonbury, and they gave me the ingredients in the right proportions that they felt. And then after that, I was buying it at Vitamin Shop. They had a version, it was all mixed together. So I figured they knew how to mix it. I don't know.
Well, that's one thing in my research I came across is that there's actually a 10-fold difference in the price between SEAC-T with sheep sorrel roots versus SEAC-T with just sheep sorrel leaves in it.
Oh.
Yeah.
I'll have to look at the bottle and see what it said, but I'm not at home right now.
Yeah, I believe that actually is a very critical element to it.
One could look on the Vitamin Shop website where they sell it. It's not their brand, but they might have some information about ingredients.
Yeah, you could buy a pound without the roots in it for $20.
I've tried this.
What's that? Oh, it looks like Paul's breaking up a little bit. Are you still there, Brendan?
Yeah, I'm still here.
My internet went out. I don't know what happened to me there. This is the problem I was telling you about. It's this motel here. It says that some other device on the network is using my computer IP address. I don't know if you know the answer. I had this problem in Greece, and then Apple told me something to do on my computer, which I've now forgotten what it was, and it cleared up the problem.
I don't know.
Anyway.
It was coming through fine, and just for that one brief moment, and now you're fine again.
Oh, okay.
Yeah.
Well, one thing was, Paul, that when you set out to do your PhD in subquantum kinetics, the university was open-minded.
No, I didn't do. I didn't work on that for my PhD, but I had planned to. Actually, that's why I went to the systems program, was to do that. But then it changed to the superwave theory.
All right.
And then I finished the work on subquantum kinetics after I finished that in '83. I was working on actually subquantum kinetics in parallel. but I had more time afterwards to push it through and get it published, you know, and all that.
And also, David Bohm's more acceptable now. Before, he was totally outlawed before. And Basil Hiley, who's in his early 80s at UC, I met him at UCL a few times. He was continuing Bohm's work with the Bohm interpretation of quantum mechanics, working with the particle physicists. I know like 10, 20, 30 years ago, but Bohm was completely ostracized.
Well, there's parallels between what Bohm was saying and what subquantum kinetics says. They viewed the 0 point as real fluctuations, not just what was the alternative view? I don't know. That it's a real statistical phenomenon. It's not that the universe is impossible to measure at that level, and we only have probabilistic knowledge. That it really is probabilistic, you know, at that level, and that's what's causing these little errors that they find. So it's a different viewpoint on things. I think I discussed Bohm in my book, and that view. Yeah.
So it's possible if things open up more, it could be that this kind of science will be studied, will be accepted. Well, when on how does it come about? You know,
we'll see after the experiments we're doing, if we can get them published and get enough press coverage. See, we're building a device in Czech Republic that will generate an ether wind. And then we're going to do experiments like Michelson-Morley experiments to show that the ether wind is there, and superluminal wave propagation, time dilation, stuff like this. Jan also already, he doesn't believe in Einstein relativity from the experiments at CERN, which show there's no length contraction. So, yeah. But revolutions are difficult. I mean, you can publish stuff like that and it can get ignored.
Yeah, it can get ignored for a long time, and then eventually someone comes about. I mean, it reminds me a bit of apartheid in South Africa. I remember the 80s, 70s and 80s. It was going on. It just seemed to go on and on and on, and nothing happened. And eventually, it gave way, and Nelson Mandela was released. And also with the Berlin Wall coming down, the Cold War you seemed to go on and on and on forever, you know. And then eventually it crumbled. So, yeah. I mean, if they have a serious energy crisis, if we run into a serious energy crisis, scientists who know about free energy might try and force it to come about.
Well, you know, there are people that they actually pay them to go on the internet and criticize people that have ideas against relativity and so on. And who is paying those people? That's a big question, because physicists wouldn't be paying people like that. And it's a political thing, you know. They don't want the black projects to be discovered, so they have an interest to pay people to ridicule people that are getting too close to what they know.
Right, the people paying to ridicule the scientists who are looking into this theory could probably be using this theory and going full tilt with it.
Well, the people that are paying them, anyway.
Yeah, exactly. So they're using it, but they're ridiculing everybody else who wants to look at it.
Yeah, a guy named, I know, Frank Ferguson, well, through internet we met. When he was young, his father was in black projects. And when he was only 8 or so years old, he had come back, he had finished a term paper on Einstein relativity in school at that level. I don't know if he was that young, maybe 10. Just, you know, general about what they would write in the Britannica Encyclopedia or whatever. And so his father happened to be meeting with some other people in the black projects at his home over coffee or something. And they heard that. And so they mentioned to him that about Einstein. The one guy said, well, I saw him, this was in the 50s. I go to Princeton, and every time when I'm there, I see him often walking with Valclavi, who's I think Hungarian physicist who had totally different views about gravitation and propulsion, space propulsion. And he said, yeah, Einstein's theories never worked, but Valclavi's did. And he also mentioned to his son, back then, he says, already we have interstellar travel, faster than light, interstellar travel.
When was that? In the 50s?
Sounds like the
50s,
secret
yeah.
space program.
That's amazing, huh?
Yeah, they've got all this stuff in Black Projects and the Black World, you know, and it's just
Brown stuff was relatively, tame compared to the stuff that they were doing.
Mhm. Yeah, oftentimes it could be side by side, and you won't even know it. They really compartmentalize areas very well that way, and I've seen a little bit of that myself. So it's very subtle.
And now Space Command is wanting to get some of this stuff out of the Black Projects by recreating it in a white world, so to speak. And they're interested in subquantum kinetics and in the secrets book, where all this stuff has been reverse engineered.
So if we keep plowing on with what we're doing, they might catch up with us. We might meet a bridge where, because if you think about it, to get it out into the ordinary world, it has to start somewhere. Because it has to start somewhere. So maybe our effort is one way to bring it out in the normal world, the ordinary world. Whereas the Black Projects are because some of these people are so compromised. If they just mention free energy, they could lose their lives because they're in official positions. They're in positions where they can't, they would be compromised if they even mention it. Whereas other people who are more low level, not known, not publicly known or anything like that, they can talk about it and no one does anything. Someone who's like a professor at a university or a military guy who's got a public position, if he came out and said, oh, this is real, they could get in a lot more trouble because of their position.
Yeah, they could lose their grants. That would be really scary for them.
Anyway, I think we should move ahead and do whatever we can in our encapsulated world. But if you can find some open-minded physicists who are probably also excommunicated because they're too far ahead of everyone else, who might like to work with us, that would be good.
I got another. There was one guy who texted me here. I asked him, he wanted to join this group, so I asked him if he's interested in what he knew about SQK and whether he would participate. And he said he had read your book and he was interested in it. He wasn't sure how much he could add to the discussion, but he was a software developer, so he said if that might be useful. This guy, Chris.
Of course, software, that's for like computer applications. That's a little different from simulation, right? I mean, it requires a lot of the basic skills, but it's going in a little different direction. But anybody who's interested, it would be good to get their views, I think.
Yeah, and then that could be one. That could be a project to go around universities, emailing different university departments. So with an email asking if they're interested in doing this. See what kind of, it might be just useful just to see what reaction one gets.
Yeah,
but I think something like if subquantum kinetics was to come out and be mainstream, that would mean that I think first something like free energy would come first, because scientists know about free energy and a number of them know about free energy, so they would have to, it would be somewhere, it would come about because it would become a necessity because of the of an energy crisis.
Right.
And then because free energy comes out, therefore subquantum kinetics is in the same line, because that's what's big about subquantum kinetics is the anti-gravity and the free energy implications of it. So then because free energy was out and people were accepting it, subquantum kinetics will come out in the same way, I think.
Well, probably retirees are prime targets because they have a lot less to lose.
Yeah.
Yeah. They, yeah. But by the way, Paul, I was wondering, did you notice any other notable observations when you're at the pyramid there in Bosnia?
Well, I've only been here 2 days. We went to the tunnels the first day, and second, and the pyramid today. I'd been here 5 years ago.
No.
They've got more radiocarbon dates. The tunnels, they've made them go further towards the pyramid. Still, they've only gone 1/3 of the way towards the pyramid. So it's a lot more excavation to do. At the rate they're going, it's going to take at least another 20 years.
Oh my. Well, when do they think it was built at this time?
I gave them, well, they had a date 29,500 or so, which I helped them convert it to 34,000 calendar years. And they use that now often. While I was here, I happened to eavesdrop on a lecture in one of the healing chambers in the tunnels, and he mentioned a radiocarbon date they got in the tunnel of 32,000 C14 years. So that would convert to like 36,000 calendar years, which makes sense. You know, I'm now preparing a history of what happened to the Earth in the last 50,000 years. And that particular time, there was a glacier wave, a Heinrich event, which indicates flooding. So one of the purposes of the tunnels would have been not only to keep away the radiation from the sun, cosmic ray radiation, but also escape from floodwaters. So it's interesting, coincides close to that date. So that predates the pyramid by 2,000 years.
Yeah. Do they have any indication of underground chambers for priests or anything like that?
Well, they have these chambers where the tunnels kind of expand into a chamber area in places, and then there's tunnels that go off in different directions in some cases. And they've got these healing stones, ceramics, in the middle of the chamber that create an energy. They have a very high ion content they've measured. They have these meters that measure ions in the air, like negative ions. And in these rooms, the healing rooms, there's very high levels of these. And the question is, how are they generated? And I have a theory that the piezoelectric waves, well, there's quartzite in the conglomerate, and also a lot of water. It's very damp. In fact, you'll find water dripping in some places from the ceiling. And so these waves are causing the vibration of the quartzite, which generates electrical potentials. So theoretically, that could split the water into hydrogen and oxygen, and might even generate oxygen and also these negative ions.
It'd be beneficial to have a source of oxygen if you're in a closed chambers and tunnels and things like that.
Yeah, people feel the healing energy. You can feel it in there if you're sensitive to it.
And they say that about the pyramids of Egypt as well. The quartz, the granite and the quartz stones have a certain electrical properties.
Uh-huh.
Just,
But they haven't found an actual beam of radiation coming from the peak like they do at the Bosnian pyramid.
All right.
Right. There's actual photographs of that beam, isn't there?
No, that's a fake. That's Photoshop. Actually, it doesn't go up that high. No, it's at least 30, maybe 10, 15 meters height above. And it sort of wanders around. It's not fixed. It's not something you can see. It's 28 kilohertz EM radiation.
Mm-hmm.
It's got some harmonics also. But this whole thing of, if some people like there's a picture of a pyramid in Mexico and they show a beam coming out the top, that's baloney,
Yeah, like the pyramid in Las Vegas,
Yeah.
the Luxor.
They have a beam coming from the top.
Uh-huh.
Spotlight, huh?
Yeah, I actually had the pleasure of flying through the beam in a helicopter.
Oh, I stayed in that when we were in Las Vegas, in that hotel. Yeah.
Uh-huh.
The elevators, they go sideways, sort of diagonal up. They got diagonal elevators.
Do they? I've never been inside.
Yeah.
I just flew over. Wow. I doubt they have the healing properties like the one in Bosnia does, though.
Oh, it could be. But I think it's made of concrete. You need to have some quartz in there. Those people that made it probably didn't know much about pyramids.
I doubt they were thinking about that from a design standpoint.
Yeah.
Yeah.
Yeah, the ancients knew a hell of a lot more than our construction engineers about healing properties of pyramids and how to make them.
And that was one theory, wasn't it, that the pyramids sent out healing energy to the whole land.
Mm-hmm.
And the water underneath, the water channels underneath the pyramid, and they're kind of the electrical circuit that the pyramid was behaved like,
Yeah, I haven't really gotten into studying that in great depth. So.
Also, what's his name? Max Ingham on Crow House. He's talking about whether our history may be different from what we think it is, And he talks about Tartaria and the lost history of Tartaria, which is like 200 or 300 years ago. And he's saying all these buildings that look like the churches were actually healing centers, and that there's a fair bit of evidence to show that because the Aborigines and the South Americans, when the Europeans arrived there, they found they were speaking Magyar, which is a form of Hungarian, and there's records when they first traveled to they first stayed in the Europeans first traveled to Australia, and they were sort of like questioning these Aborigines. They found in the history notes that the words they were writing down were very similar to Magyar, which is what Hungarian. And he was saying that Hungarian is one of the purest languages on the planet. You can express the most detailed emotions with Hungarian. And he's not saying he wasn't saying this is really what it was, but he's saying there seems to be quite a lot of evidence. And it's not just him; it's a number of other people. And talking about the mud floods in Europe, so he's saying because when buildings are when you excavate underground layers and layers, he's saying that these layers came from mud floods that were kind of all over Europe, and that's why the buildings, the road, the historical levels going down to the Romans. That's why, and also that the ancient ruins of Rome and Greece he was noting that the ruins, they don't look all that weathered, and that they could be similar to the Washington DC, the monuments in Washington DC and other places in Europe and Australia and Japan. He's thinking that maybe they could be more similar age, because he was saying carbon dating is notoriously not as accurate as it's made out to be. You know, so anyway, he was just putting it out there. He's saying, he's not saying that this is definitely it, but he's saying there's a lot of evidence to support it.
Yeah, they also keep from us that there's at least a few million aliens living on our planet, mostly underground.
Yeah.
Yeah, it's amazing what the general public is just not aware of.
Yeah.
And, you know, I'm speaking from being a former member of the general public. You know, so. By the way, I did look up there on the vitamin shop that CIT, and they didn't specifically mention the roots, and although it was priced accordingly, so it was what you would expect to pay if it had the roots in it. But I just posted a link in the chat to a website that actually speaks about the roots, and you can actually find sources and links there of variations of the tea where they'll guarantee you that they have at least 10% sheep sorrel roots in there. So if you're interested, I linked to that in the chat.
Well, I'm not doing the alternative therapies right now. I'm just going to try to boost the immune system with, I'm still taking mushroom juice. I guess that's alternative. And I use a pulsar that puts out healing frequencies, electromagnetic. So that plus the pyramid energy and pyramid water. Here's a bottle of pyramid water. And my wife has tested it with pendulum, has a lot of energy. So all these things, my goal is to boost the lymphocyte count, so the lymphocytes can clear up whatever debris is left that the radiation didn't get. They found, there's been studies that the chemo and radiation therapy can actually stimulate the immune system to go after stuff that it didn't get. But people whose immune system is not in good shape don't get that benefit. And so the goal is that's 3 to 5 weeks after you do the treatment, they say, is when you should try these immunotherapies. And so I'm here at the right window to try to do that. I measured my T cells and white blood cells before, and going to do it again after to see if there was a change. Sam, the archaeologist here, is interested in collecting data on that. So he's helping out on that. He actually gave me as a gift 12 bottles of this stuff. Normally they sell this, just like a quarter of this, they sell for 10 euros. Mm-hmm. So he must have given me about $1,000 worth of water.
Wow.
They do it to raise money for the foundation.
What was the name of that again, Paul?
The water?
Yeah.
They call it pyramid water. They get it from the tunnels.
I got it.
By the 28 kilohertz radiation and the ultrasonic radiation and the ions floating around. And there's this strange phenomenon which you can find on the internet. I think I put some links to it, mentioned it on my website about the Bosnian pyramids, where they see, if you take videos, sometimes, not always, you'll see these little white things floating around. Reminds you of that movie Avatar with the little white spirits from the tree, remember?
Mm-hmm.
And so nobody knows what those are, but it's very interesting.
Wow.
You don't see it with with your eyes, but your camera is able to, has a greater range, goes into the ultraviolet infrared a bit, and captures that.
Oh, this person might be. You might find this person interesting. Have you heard of her, Anita Morjani?
No.
She back in about 10 or 15 years ago, she was was riddled with cancer. Had cancer the size of golf balls on her neck.
Uh,
She was doing a lot of alternative healing, trying to. She was a bit confused between alternative healing and mainstream healing. What happened was, I mean, there's a number of videos on her, at London Real as well, when she talks about it. She had a near-death experience while she was in hospital. She was so bad with cancer in hospital, all over her body, and she passed out on the operating table. And she had a near-death experience, met her father, her deceased father, who told her to go back and live her life fearlessly. She came back into her body, and she started to feel better. A few days later, the surgeons wanted to cut the cancerous tumors out, and she said, no, just leave them there. Eventually, after a few weeks, months, the tumors just shriveled up and disappeared. And she was talking about the difference between people going for mainstream treatment and alternatives. She says, just stick with, because she was very confused between the two when she was getting treatment. She said, just stick to one. Just either stick to mainstream or stick to alternative, and just stick with that. And she talks about it. I mean, she's on here talking to London Real, but so she just, I thought it might be interesting. She gives some interesting advice and stuff like that.
I'll write her name. More Johnny.
I might also offer one other suggestion is if you have access to lots of raw nuts and seeds, I would definitely incorporate them into your diet because the research of Dr. Warburg, who's a Nobel Prize winner, had shown that oxygenated cells cannot become cancerous, and you need the oils and things like nuts and seeds to get the oxygen from the bloodstream into the cell.
I can add more to my breakfast.
Yeah, a handful.
I always do put like walnuts and things like that.
Yeah, that's great, especially if they're raw, unadulterated.
Right.
Mm-hmm.
I would have thought the chlorine dioxide was quite good. Did you have problems taking it? Meaning having to take it regularly was a bit of an issue.
Taking what?
The chlorine dioxide miracle mineral solution. Was that sort of difficult taking it all the regular?
Well, what I was doing, mixing it up with a little DMSO and applying it to the prostate area so it would soak in. But I didn't do it regularly. I was doing some other things. I think it's good for toothaches. You swish that in your mouth, and sometimes I have a little ache, and I do that, and it will go away.
Yeah. Anyway, I think what Anita Morjani's advice was to take one treatment and just stick with it. You know, she was getting so confused. People were telling her to do. They were saying, you can't do mainstream. You have to do alternative. And the mainstream people were saying, no, you can't do alternative. You have to do mainstream. And she was totally confused. You know.
Well, I was doing alternative for a long time, waiting for this technique to finally be that I could qualify for it. It was developed in Germany, this targeted therapy. I couldn't do it 3 years ago. I wanted to do it 3 years ago, but they would only take people that had metastasized cancer. And mine at that time, the PET scan showed it was localized. So basically I had to wait till my cancer to get worse, because apparently the alternative therapies weren't keeping it in bay. And then I qualified because I did the PET scan a month ago and showed it had metastasized. So I then qualified for this treatment.
Well, you got us in your corner, Paul. I know a lot of people who have a lot of experience beating cancer, so you're welcome to contact me or at any time.
Well, I hope I beat it. It's just a matter of getting the immune system ramped up. I feel I have more energy now.
Well, that's a good sign.
Yeah.
Yeah.
I had
Before I couldn't do that much work, you know, it was mostly taking all these supplements and things. Now I've actually changed my diet away from being very much vegetarian. So I get more meat in the diet every day because the meat helps stimulate lymphocytes to create lymphocytes. So that's the main thing, is to get your army going.
Yeah. Positive attitude. Yeah. Yeah.
Yeah, things are going well. I mean, all this research throwing down relativity, and I had an idea here at the Bosnian pyramids how it could send electrons faster than the speed of light, which would put CERN out of business because they can't go faster. So we could get even faster particle velocities if they wanted. They'd have to come to us then.
That definitely be a higher energy. That's for sure. Yeah. Would you agree? Well, you think the energy would keep up with the velocity?
What do you mean?
With the like 1/2 mv squared relationship.
Yeah. Well, in this case, you're not dealing with a light wave, but a actual particle, sending the particle faster than light. And if you could succeed in doing that, it would show that it's possible to do faster than light space travel with actual material objects. And we already know they wouldn't pancake because they don't observe that at CERN.
Yeah. Well, that would be awesome. Yeah, got a lot to do there, Dr. LaViolette.
Yeah, I want to keep going and finish these interesting projects for sure.
Absolutely. Yeah. Well, like I said, I'll be definitely praying for you, and God bless you. And yeah, I'm looking forward to our next meeting.
Okay.
Okay.
Are we bringing it to a close then? It's been a while, huh?
Yeah. Okay. I'll bring it to a close now. Okay. So I'll arrange one for next week and see how far we've got by then.
Okay. Very good.
Okay, and good luck with your treatment, Paul. I hope it works out.
I'll still be here in Bosnia. I think, let's see, I'll be here next Sunday. Yes, definitely. I'll still be here at that point.
Okay. Enjoy your trip.
Thank you.
Okay. Cheers. Bye.
So long.
Bye.
Bye.